Okay, so first things first, we've got several variables in gas laws of the different things we can measure about a gas. Remember from unit 1 that a gas is a state of matter where all the atoms are really far apart from each other, like none of them are touching and they're all moving constantly. And it turns out, if you watched Ed Puzzle Unit 10 Part 1, you learned that temperature is actually not a measure of heat, it's a measure of movement. Heat involves temperature, but it's not, they're not the same thing. Temperature is a measure of how much kinetic energy, how much motion a gas has, or anything has, but like right now we're talking about gases. So how much those gas particles are moving, how fast they're moving, how much they're bouncing off of stuff, that amount of motion is actually what temperature is measuring. And we're using a new unit of temperature, where in the past you've probably pretty exclusively used Celsius in your science class or maybe Fahrenheit. We're not using Celsius anymore. We're using something called Kelvin, which is what's called an absolute zero temperature scale. Basically, what happens with Kelvin, and I'm going to put this in the chat, but they took the Celsius scale, where 0 is the freezing point of water, and they like bumped it back so that 0 is now 273 degrees lower, where the temperature that is absolute zero happens to be. Absolute zero is the lowest possible temperature where all motion stops. So like if temperature is a measure of kinetic energy, a measure of motion, then if there is no motion, there's no temperature. Yeah, if you're measuring motion and there is none, then that's no motion, that's no temperature, because temperature is not heat, temperature is actually motion. So we call it absolute zero because it's absolutely zero motion. And that is negative 273 Celsius. So we actually invented a different temperature scale called Kelvin, where we took Celsius and we just like dragged 0 down to that absolute zero. We dragged it down 273 degrees so that 0 Kelvin is the lowest possible temperature, which means you cannot get colder than that. You cannot have less than 0 motion, like negative motion's not a thing, right? So then that means there's no negatives. So the advantage of Kelvin is that there are no negative temperatures. And so we're going to use that here because negatives would really throw off a lot of our work. So we cannot use Celsius. We would always convert to Kelvin by just adding 273 to it. So that's that. We've also got pressure, volume, temperature, and moles. There's this chart in your notes of what each unit measures. And I'm going to copy and paste that chart into the chat as well, where pressure can be a unit called atmospheres, ATM, a unit called millimeters of mercury, mmHg, or a unit called kilopascals. Those are 3 different semi-metric units, as opposed to like American units are usually like pounds per square inch, which is like a hassle and a half to use. So we'll use any of these 3 that are kind of metric adjacent. We're not going to use the American ones because the conversions are terrible. Like all American units, basically. Volume is milliliters or liters. For this unit, again, temperature, we're going to use Kelvin, specifically not Celsius. If you're given Celsius, you have to change it to Kelvin before you can do anything. And then the number of moles will be a lowercase n, where basically we use n because M was already taken. Lowercase m is meters, and it's also milli, and capital M is something called molarity. So we needed a different letter. So we picked n for number of moles. So that we have those units there. These units are just something you're going to need to keep in mind as we look at the daily check. So moving right along, before we can get to the daily check, we also need to talk about our formula, the combined gas law, which is what this entire daily check is about. the combined gas law compares what a gas is like before and after, like before versus after a change. And in its full form, it's this P1V1 equals P2V2 situation where then it's also like over N1 T1 equals N2 T2. It's kind of like a hot mess of an equation. There's a lot going on there. Which again, I'm putting it into the chat for you. But basically, there's a lot of variables. The P, V, N, T, those are pressure, volume, moles, temperature. The ones and twos are comparing like the initial, like the starting conditions versus the ending conditions are the twos. So like before the change, what was the pressure, volume, moles, temperature? That's P1, V1, N1, T1. After the change, it was P2, V2, N2, T2. Like what is it at the end? That's what this is comparing. The nice thing about this equation is that it's like so extra, and sometimes in a problem you actually don't need all of these variables. Like some problems just won't mention moles, and so you could just like cross it right out of this equation. Or like some problems won't mention temperature, and you can just cross it right out of this equation. Or like whatever, like maybe it's not going to mention pressure and it's only going to mention volume and temperature, and then in that case you would do, okay, well I'm really just doing V1 over T1 equals V2 over T2. Like there are options for you with the combined gas law here. So I'm gonna recommend, if you look at what I put in the chat there, I'm gonna recommend you maybe like copy and paste that into your slide, that the combined gas law compares before and after a change. That might just be handy notes to have for yourself later, just a thought. And I'll give you, I don't know, like 30 seconds to do that before I move on. Just paste that into your slide somewhere. That's my advice. It's in the chat, so you can copy it, like highlight and copy it out of the chat. And like 10 seconds. All right, moving on. Let's look at daily check number 1. So it gives us a question. At a pressure of 405 kilopascals, the volume of a gas is 6 liters. Assuming the temperature remains constant, if the new volume is 4 liters, what will the pressure be? And then it asks, what are the givens? So first of all, this is, what are the givens is question 1. But questions 2, 3, 4, I'll use the same like setup. Like this little paragraph of like at a pressure of 405 kilopascals, blah, 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 blah. That is the same on question 1, 2, 3, and 4. So just be aware of that. But they're asking us like sub questions basically. So question 1 just wants us to read this and say, what are the givens? You may notice there are multiple givens in this problem. We've got 405 kilopascals, we've got 6 liters, and we've got 4 liters. So this is, we're moving on from our days of mole conversions and stoichiometry where there was like usually only one given. And now we're going to have multiple givens and we have to identify them. So if you look at like the answer choices in daily check 2, question 1, it's asking us to pick variables. And the way you're going to pick those variables is based on the unit. So like kilopascals is a measure of pressure. So that tells you that this given 405 kilopascals must be a P, pressure. Similarly, liters, L, that's going to measure volume. So the 6 liters and the 4 liters are both volumes. When you're trying to pick if it's P1 or V1 or P2 or V2 or like whatever, the ones and twos, just go with what order they gave it to you. Okay, at a pressure of 405 kPa, that's the first pressure they gave you. So I'm going to name that pressure 1. Okay, then it says the volume of a gas is 6 liters. That's the first volume they gave me. I'm going to name that volume 1. Assuming the temperature remains constant, if the new volume, new is code for 2. They're saying like after it changes, which would be 2. So that means 4 liters must be our V2, which makes sense because we already identified a V1. So these are my 3 givens, P1, V1, V2. Those are your answers to question 1. You got to click all 3 of those on question 1 on the daily check, by the way. I'm going to give you, again, a quick moment if you're trying to write down anything. Or you can put those answers straight into your daily check. That's fine with me too. You do you. But I'm going to move on real soon. So make your choice, basically. I also, something is wrong with how it's grading the daily check, just FYI. I don't know why it's messing that up, but when you do submit your daily check, it might not give you a grade right away. I can't figure out what Schoology is doing. It's making me auto grade something, but I mean, it's trying to make me hand grade a question that has answers programmed in. So I don't know what it's doing. And I'm still trying to figure that out, but just FYI, it might not give you a grade right away. I'm like messing with the settings, trying to get it to like do something different and actually grade all these, but I just don't know what it's doing. Okay, anyway, that's enough time. Let's look at daily check number 2. Again, this is the same like setup at a pressure of 405 kPa, blah, 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 blah. This time, question 2 is asking us to identify what is the unknown. What is the unknown? So again, we're going to need to just like read the problem. It says, what will the pressure be? So the word pressure there should be hopefully a pretty big clue that our unknown is going to be a P. And then we have to figure out if it's going to be P1 or P2. And there's 2 ways we can figure that out. First of all, just reading the problem, it says, what will the pressure be? It's implied like after a change, what will the pressure be? And after a change would be 2. But also, we already know that they gave us P1. So if they gave us P1 and we're looking for a P, it's got to be a different P. It must be P2 that we're looking for. So this, what will the pressure be? The unknown has to be P2. Again, I'm going to give you a second to write down anything you need to write down or put it into your daily check directly. And then I'm going to move forward. Keep moving forward. Okay, I think you're all done writing. People who are trying to write seem to be done. So let's move on. Daily check 2, question 3 asks us to identify the equation. There's 2 things that come into play here. First of all, you're going to start with the combined gas law, P1V1 over N1T1 equals P2V2 over N2T2. I know that's a lot going on there, but that's where we're going to start. Then you look at your givens, which we marked that they gave us P1, they gave us V1, they gave us V2. Okay, and look at your unknown. We marked that the unknown was P2. The variables you need are the ones you marked as your givens and your unknown. And if there's a variable you did not mark because they did not give it to you and they did not ask you for it, then you do not need it in this problem. So like this problem says nothing about moles, doesn't even bring them up. Moles are not part of this problem. We can just cross moles out of this equation. So instead of P1V1 over N1T1, now we're looking at just P1V1 over T1. The problem does mention temperature. It says temperature is constant. So if it's not changing, it's not a T1 and a T2, it's just the same number. That means we don't need T either. So I'm gonna cross out T1 and T2. That is leaving me with just the equation P1V1 equals P2V2. Please remember when they write it, P1V1, that implies they're multiplying. So this is like P1 times V1 equals P2 times V2. Just throwing that out there. That's what that means. There you go. So that is the equation we need. P1 times V1 equals P2 times V2. And again, I'll give you a quick moment to write down anything you want to write down or put directly into your daily check, anything you want to put, whatever, be my guest. And I think everyone who is writing is mostly done. I think I see one person still writing. Okay, I think you're all done. All right. So what do we do once we pick an equation? We've figured out our givens. We figured out our unknown. We figured out the equation. Question 4 asks us to calculate, which means we're going to need to like plug in numbers. So like P1 we labeled was 405. So instead of P1, I'm going to like plug in that it's 405. And that's going to be times V1, which we labeled was 6. So instead of V1, I'm going to plug in 6. So I have 405 times 6 here. And that's equal to P2, which we don't know, times V2, which is 4. Right? I will point out that P2 is just a variable. Like, you don't have to be afraid of it. But if it makes you uncomfortable to use P2 as a variable, you are welcome to just put X there. That's fine. Like, you could put 405 times 6 equals X times 4 just as easily as you can put 405 times 6 equals P2 times 4. Either of those is fine. It does not matter to me in the least. I know there are some math teachers who might get mad about it. I don't freaking care. All right. Do what makes you feel more comfortable. It's 2021. Everyone should just do what makes them feel safest, because that's our apocalypse we're living in right now. Okay, I'm sorry, that was bleak. I probably shouldn't have said that. Anyway, take a moment, write down anything you feel the need to write down, and I'll be changing the slide momentarily, but I can see several of you are still writing, so I'll give you a quick second. Whoops, that was a Grammarly commercial just popping on, sorry. I'm gonna get to that in just a second. Timothy, give me a quick second. It looks like everyone's done writing, so yeah, let me move on. Okay, so for number 4, they want the answer. That means you're gonna have to actually calculate, right? So like simplify, like the left side says 405 times 6, so like do that math. 405 times 6 is 2430, and that's gonna equal like basically 4x. So how do you solve for x? How do you isolate the variable? How do you solve? What do you do? How do you get rid of that 4? Get x by itself. Anyone remember algebra 1? You got to do the opposite of what's happening to x. So if x is times 4 and we need to do the opposite, then we're going to have to, don't say subtract. Oh, we're making me real. Divide. Thank you. Beautiful. Yes. Thank you, Mallory. Thank you, Nati. Thank you, Liam. Great job. We divide by 4. And if we do it on one side, we got to do it on the other side. Okay, thanks, Brendan, for letting me know. So we're going to do 2430 divided by 4. You get 607.5. And that's your answer to number 4 on the daily check. That's what goes in that box in Schoology. Okay. Looks like most of you are done writing. Again, if you're not, wrap it up. And I'm going to talk about one more type of question that's on the daily check. So question 1, 2, 3, 4, it was like the same mathematical setup question, and it was like just sub questions, right? Like part A, basically B, C, D for given unknown equation answer. Number 5, 6, 7, 8 does that again. 9, 10, 11, 12 does that again. And then there's 3 multiple choice questions at the very end of the daily check. I'm going to talk to you about how to do those multiple choice questions as well. Looks like, I think y'all are done writing, all of you, so I'm going to go ahead and change the slide. For those multiple choice questions, there's 3 of them at the end. You need to know what relationships, like mathematical proportional relationships are. So this is more vocabulary for you about direct and indirect, or direct and inverse proportionality, which sounds fancy, but it's not that bad. So you can have directly related or directly proportional stuff where they move in the same direction. So basically what that means, and I'm going to put this in the chat as well, and I highly, highly advise you copy and paste it into your own Pear Deck so you have it. Directly proportional means they increase or decrease in the same direction, either both going up or both going down. Inversely proportional means that they increase or decrease in opposite directions. If one goes up, the other goes down. They're always inverse, they're always indirect, they're always opposite. If one goes up, the other goes down. So, so again, I highly advise you take what I just put in the chat and copy and paste that into your Pear Deck. But yeah, directly proportional, they increase or decrease in the same direction. So like if pressure goes up, temperature goes up. If volume goes down, temperature goes down. Inverse or indirectly proportional means that they go in opposite directions. If one goes up, the other goes down. So like pressure goes up, volume goes down. Volume goes up, pressure goes down. They are inverse, they are opposites. This is an open notes class, so you do not have to memorize this, but you will get asked about it. So I'm going to just straight up tell you, and again, highly advise you to write it down somewhere. The indirect or inversely proportional relationship is pressure and volume. Pressure and volume always move opposite. The direct relationships are pressure with temperature and volume with temperature. Basically, temperature is going to be direct with anything. Pressure and volume are opposite each other. So again, and that's something I would highly advise you to copy and paste from the chat where I just put it and stick that somewhere in your Pear Deck slide. In fact, actually, I'll change the slide so we have more room on the next slide where you can put that part. I'll give you a second to catch up to me. I can see a lot of you are still working on the copy paste situation. Okay, I think you're all done typing. So looking at this last thing, daily check 2, question 13 is the first of these multiple choice questions. And again, the takeaway here is knowing what relationships are indirect or inverse and what relationships are direct. So this question, number 13, asks what happens to pressure if you increase temperature? What happens to pressure if you increase temperature? Well, we know that pressure and temperature are directly proportional. So that means if one goes up, the other goes up. That's what direct means. If one goes up, then the other goes up. That's what direct means. So they said increased temperature. That means pressure also needs to increase. So it's not going to be C or D, because those both say decrease. It increases because temperature and pressure are either directly or indirectly related. Directly is when they go in the same direction. That's why it's called directly. They either go both up or both down in the same direction. So that means this is going to be A, increases or decreases. It increases because they are direct. Okay. That's all I have to say about this daily check. You need to finish it yourself.